The scientific method is what is credited to Sir Francis Bacon. It is a process for testing propositions about the natural world. Only by subjecting questions to the rigors of experimentation and review can we potentially arrive at the truth. How many steps are there in the scientific method? Depending on what source you turn to or who you ask, the number may vary. I believe the textbook has 4. I see sometimes as many as 7. But the general rundown is this. First, you make an observation, then you formulate a testable hypothesis about that observation. You then design an experiment that tests your hypothesis. You next actually test this hypothesis by running the experiment that you've planned. And then finally, based on your findings from that experiment, you either accept or reject them. So the hypothesis that you test has to be something that can either be true or false. It has to be something reproducible, meaning it has to be something that you could do again or others can do again. It's very important to have peer review in science. So the idea that a hypothesis must be falsifiable is key to science. And in fact, it is what has kept some subjects that captivate us. Is there an afterlife? What came before the Big Bang? Are there ghosts? Stuff like that. It's kept that more in the realm of philosophy or theology, etc., which is not to say that scientists don't have opinions about it or don't think about it or anything like that. It's just you can't run experiments on those. Just like some physicists talk about a possible multiverse in which our universe is just one of many. Many others insist that's not science because you can't run a test on it. You can't get in a ship and go check out those other universes. You can't observe them from here, so there's no way of knowing, so it's not science. That is very key to science. You remember we talked about in the last unit, Galileo had made science turn from something that was qualitative to something that was quantitative, so measurement is key. So your hypothesis can't be a value statement. It can't be something normative like attending school is good for you. It's beneficial for children to show up to class. It has to be something you can actually run a test on, such as students who regularly attend school perform better on testing than students who don't. So few theories actually bear out in a way that they become scientific law. The rare ones that do and that pass the muster and are tested over and over again and tested by others in the field eventually can become, but they are very few. Very few theories get borne out into becoming scientific laws. And if there's any issue with it, if you find even one exception, it's no longer a scientific law, which is again why there's so few. I mean, an example is Newton's law of gravitation. What he observed about gravity, which we covered last week, that's one that we found no exceptions to that. Gravity is still something kind of mysterious to a lot of physicists, but nothing has been found that undercuts what has been discovered so far. Another is thermodynamics, which the laws there say that in a isolated system, energy can neither be created nor destroyed. The laws of thermodynamics also tell us in an isolated system, entropy, which is another word for disorder, increases. So those are ironclad. We have not found exceptions to those, so those reign as some of the few scientific laws that we arrive at through the scientific method over time. Everything else is up for second guessing and continuous testing. That's why we have a scientific method.